So if I multiply both of those, I'm going to end up with 2 the square root of x plus 1 minus 2 the square root of x plus delta x plus 1. All of that divided by the square root of x plus delta x plus 1 times the square root of x plus 1. All of that divided by delta x. And that's not the prettiest line of work I've ever seen, but it gets the job done. And let me do this just to help us understand, because I don't want to have any misunderstanding that it's just the limit of the numerator. It's not that. Okay. Now, what can I do with this? Oh, let's talk about this just for a moment. Why do I go to all this bother? Why can't I just use direct substitution right up here? Yeah, it's this delta x, isn't it? Okay, got to get rid of that factor of delta x. So that's why we got to do all this work. Now, down here, do you see that as a fraction? Delta x divided by 1? What do you know about dividing by a fraction? Yeah, mine is not the reason why. Just invert and multiply. One of those little, phrases that you might have learned in elementary school. So if I take this and I multiply by 1 divide by, okay, so I'm going to take this and multiply this. I'm going to just kind of move this over here and say I'm going to multiply by its reciprocal. And that's no longer down there. I'm now multiplying the whole thing by that. Then I don't have a fraction divided by a fraction. Okay, that's one of the advantages now that I have here. Have we done anything that you haven't already done back in elementary school or Algebra 1? No. It's all the same thing. It just looks so much more difficult. We never would have given a student in Algebra 1 a problem like this. Not that we couldn't, but that, your brains back then aren't ready to accept things like this. So you guys are good now. So here we go. I've got this fraction times this fraction. So I can, I'm going to do a couple of things here. Here's my fraction line now. Here's my delta x. Here's my, whole denominator now. In my numerator, I got a common factor of 2. I'm going to factor that out. Now, I recognize that I'm having all the fun up here. I'm the one writing it down and thinking about it and telling you what step and all this stuff. At this point, this is like your homework problems. For some of you, I'm not giving you enough time to process it on your own, and I realize that. That's because we're in college when I don't have the luxury of slowing down very much. So what you need to do with this problem, make sure that you go back, take your notes, cover up all of this work. It's kind of like doing this. Cover up all this work and do it for yourself, okay? Make sure you can do a problem like this by yourself before next Thursday, without any hints, without any looking at anyone's work or any help. That will tell you that that will give you the confidence and tell you that you can do this. Okay, so here we go. Let's proceed on. I've got now this problem. Now, there is an algebraic move that whenever you have a problem like this involving radicals in the numerator, there's an algebraic move. You've done it before. What is it? We use the conjugate because we want to do what? Rationalize. I heard it. Yeah, not the denominator, though. The numerator, okay. And when you say rationalize the numerator, you're saying I want the numerator to become a rational value. And it's not rational now because it's got square roots in it. Okay, and most of the time, except for the values of 4, 9, 16, 25, and so forth, those are irrational values. Okay, so how do we rationalize the denominator? Or, excuse me, I said it wrong. Rationalize the numerator. And someone said it over here, we use the conjugate. Okay, now, this is what tripped up some of you on the last quiz. You thought you were using something of a proper move. You didn't use the conjugate. Instead, you squared the fraction. Did I mention that? Did we go over this on Tuesday? Okay. You squared the fraction. And I think that it was I think it was this class, not business calc. But anyway, let me just talk about it. It was like taking 2/3 and saying that's the same thing as squaring this. Are those the same value? No, they're not. Okay, so you can't do that. Also, if you square this, otherwise make this a negative, are you really getting rid of all the radicals? No. So, be very much aware of that. It might have been a business calc problem in the quiz last time. So I'll just forewarn you that that happened, and it may happen to some of you. Okay, so don't forget now, this is the same thing, Akeem. We need to multiply by a value of 1. And I don't do that unless I have a fraction whose numerator and denominator are exactly the same thing. Okay, so if I multiply the numerator by its conjugate, FOIL, first terms, the square of the square root, so that's going to be x plus 1, minus, and now I have the square of the last terms, so the square of the square root is going to give me x plus delta x plus 1, divided by, now hang on to your hats, this is not going to be pretty, in fact, if it helps, we'll put some parentheses in here, make sure we understand what we're dealing with. I see semester after semester students trying to take shortcuts so they don't make these radical signs long enough, they don't make the fraction line long enough, they don't use parentheses. I interpret it as you write it. And if you write it to mean something different than it should be, that's all I can take it as at face value. So, now, what do you think about that line? I'd like everyone to be able to participate. So here we go. I'll go back and show you.
What do you mean by that line?
This right here. This right here.
Oh, like the denominator.
No, not just the denominator. That whole line of work. Now, someone said, I can't cancel the delta x yet. Yeah, I can't now. I can't yet, but what can I do? So I'm going to go up here. Is there any way to simplify this numerator? Okay, so I could have 2 to the quantity x plus 1. Be sure you distribute it all the way through. Do you know what kind of error a lot of students make on that? Yep, or they don't put parentheses in to begin with, so they don't know they have to distribute it. At this point, when you get and we'll leave the 2 out there, but at this point, when you get everything, all those other parentheses out of there, what must happen? Again? Jen? I can't hear you. So if I combine the like terms, I'm going to end up canceling every term except those that have what in them? Delta x. Why is that important? I can't cancel it until I factor it out. So I'd end up with -2 delta x. Now this is it's like, well, yeah, that's the only thing left. But on some problems it's not. So don't forget that you need to factor out the delta x. Once it's factored out, then I can cancel. But wait. There's still some delta x's down here. Aren't those delta x's in the denominator the problem, James? Yeah, here's my question again. Aren't those delta x's in the denominator still a problem? I've canceled the factor out, but aren't these delta x's still a problem?
I don't think no,
Why not?
because you still have those x's that are down there.
At this point, what's my ultimate goal? I want to be able to do what?
You get rid of all of that.
I want to be able to get rid of them by doing what? Direct substitution. Okay. So at this point, can I use direct substitution? No. I wouldn't say no thinking. I want you to think, okay? But I want you to say it with confidence. Can I use direct substitution and not make this undefined by making this 0?
Yeah, you can.
Yes, I can. Okay, now that's an answer I want. It's full of confidence, okay? That's the answer I want. Okay, so the next step then would be -2, and let's see, if I substitute in 0, I get x plus 0 plus 1 times the quantity x plus 1 times the quantity, the square root of x plus 1, plus the square root of x plus 0 plus 1. Okay, so what was wrong with the last one? Okay. Okay, good. 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 You guys are good. Look at you. Couple of I don't knows. Very good. Okay, very good. What's wrong with it? If we go back here, is it correct to still carry that limit? We've already done direct substitution, okay? So that would be incorrect to have that there, so we're going to erase that. It's already done. It's like having the square root of 5, or 25 equal the square root of 5. You don't keep carrying the square root sign. Okay, so we can simplify this by saying -2 divide by, I don't know if I have enough room here. We need to start down here. By the way, I also picked up over the years that some students don't like to use equal signs. Some people, let me just show you what I'm talking about. Some people will do things like this. What do you think I interpret this to be? Yeah, 2 fractions multiplied together, okay? You know, if you need more lead, I'll give you some. Just put a little equals in there. Then you're expressing what you want to. Okay, so let's make sure about that. If I do all this, I have the square root of x plus 1 plus times the square root of x plus 1. That is just resolved as, well, if I have the square root times the square root, it's the square of that, so it's just x plus 1. Is that what you said? Maybe I misunderstood you. Then I have here, this is going to be the square root of x plus 1 plus the square root of x plus 1. So this is going to be 2, okay? And then I can cancel the 2's and so forth. I have -1 divided by x plus 1, the quantity square root of x plus 1. Could we write that in different ways? Oh yeah, we could write it as -1, and we could have x plus 1 to the 3/2 power. You know, other things can be written. And the answer in the back of the book could be different than even that. Some of you have been always taught never to leave a rational or an irrational in the denominator, and we got technology now. It's okay. Oh, thank you, thank you. Okay.